In an incorrect wiring scenario, the hot and neutral terminals on the receptacle are switched, so that the hot wire is connected to the neutral terminal and vice versa. The plug-in tester is fooled because it relies on a simple continuity test checking for path between the hot and neutral terminals. In the case of reversed wiring, the continuity test will still pass, indicating that the receptacle is wired correctly. The plug-in tester only checks for continuity, not for correct polarity. In a reverse wiring scenario, the current still flows through the receptacle correctly, but the hot and neutral wires are not connected to the appropriate terminals. This incorrect wiring scenario is dangerous and can lead to electrical shocks or fires. It's important to use a more reliable receptacle tester, such as a polarity tester or a 3-light tester, to properly check receptacle wiring. Electrical receptacles, also known as outlets, are the points where electrical power is accessed to operate appliances, tools, and other electrical devices. The safe and proper functioning of receptacles is crucial for preventing electrical hazards, protecting equipment, and ensuring the overall safety of an electrical system. A standard electrical receptacle typically has 2 or 3 openings or slots. The 2-slot receptacle has a hot slot, which is the smaller slot, and a neutral slot, which is the larger slot. The 3-slot receptacle includes both the hot and neutral slots, as well as a ground slot, which is the rounded opening. The hot wire, typically black in color, carries the electrical current from the power source to the receptacle. The neutral wire, typically white in color, provides a return path for the current back to the power source, completing the circuit. The ground wire, typically green or red copper, provides a path for stray electrical current to flow back to the power source in the event of a fault, such as a short circuit or equipment failure. Receptacle testers are devices used to verify the correct wiring and functionality of electrical receptacles. These testers can identify common wiring errors such as reversed hot and neutral wires, open ground connections, and other faults that could pose electrical hazards. There are several types of receptacle testers available, ranging from simple plug-in testers to more sophisticated devices with advanced diagnostic capabilities. Plug-in receptacle testers are the most common and basic type of tester. These testers typically have 3 lights that illuminate in different patterns to indicate the wiring status of the receptacle. The light patterns correspond to various wiring conditions, such as correct wiring, open ground, reverse polarity, hot and neutral reversed, and hot and ground reversed. Polarity testers are more advanced receptacle testers that can specifically identify reversed hot and neutral wiring. These testers typically use a combination of lights and audible signals to indicate the polarity of the receptacle. 3-light testers are another type of receptacle tester that uses 3 lights to indicate the wiring status of the receptacle. These testers are similar to plug-in receptacle testers, but they may provide more detailed information about the wiring condition. An incorrect wiring scenario that can fool a plug-in receptacle tester is when the hot and neutral wires are reversed. In this scenario, the hot wire is connected to the neutral terminal on the receptacle, and the neutral wire is connected to the hot terminal. This condition is also known as reverse polarity. Plug-in receptacle testers typically rely on a simple continuity test to check for a path between the hot and neutral terminals. Continuity refers to the presence of a complete and uninterrupted electrical path between 2 points in a circuit. When a plug-in receptacle tester is inserted into a correctly wired receptacle, it detects continuity between the hot and neutral terminals, indicating that the receptacle is properly wired. However, in the case of reversed hot and neutral wiring, the continuity test will still pass, even though the receptacle is wired incorrectly. This is because the tester is only checking for the presence of a complete circuit, not for the correct polarity of the wires. The current still flows through the receptacle, but the hot and neutral wires are connected to the wrong terminals. There are several reasons why a plug-in receptacle tester can be fooled by reversed hot and neutral wiring. Firstly, the tester only checks for continuity, not for polarity. As mentioned earlier, the tester simply verifies that there is a complete circuit between the hot and neutral terminals, regardless of whether the wires are connected to the correct terminals. Secondly, the current still flows through the receptacle correctly. Even though the hot and neutral wires are reversed, the current can still flow from the power source through the receptacle and back to the power source, completing the circuit. This means that appliances and devices plugged into the receptacle may still function, even though the wiring is incorrect. Thirdly, the tester does not check for voltage potential. The tester does not measure the voltage potential between the hot and neutral wires, which would indicate the reverse polarity. If the tester measured the voltage potential, it would detect that the hot wire is connected to the neutral terminal and the neutral wire is connected to the hot terminal, revealing the incorrect wiring. The consequences of reversed hot and neutral wiring can be severe. Reversed polarity can create a dangerous electrical condition that could lead to electrical shocks, fires, and equipment damage. Firstly, electrical shocks can occur when a person comes into contact with a metal part of an appliance or device that is connected to a receptacle with reverse polarity. In a correctly wired receptacle, the metal parts of appliances are typically grounded, providing a safe path for stray electrical current to flow back to the power source in the event of a fault. However, in a receptacle with reverse polarity, the metal parts of appliances may become energized, meaning that they are carrying electrical current. If a person touches an energized metal part, they could receive an electrical shock. Secondly, fires can occur when reverse polarity causes overheating in electrical wiring and components. When the hot and neutral wires are reversed, the current may flow through unintended paths, such as through the grounding system or through the appliance itself. This can cause the wiring and components to overheat, increasing the risk of a fire. Thirdly, equipment damage can occur when reversed polarity damages sensitive electronic devices. Many electronic devices are designed to operate with a specific polarity, meaning that they require the hot and neutral wires to be connected in the correct orientation. When the polarity is reversed, it can damage the internal components of the device, leading to malfunction or failure. To prevent the dangers of reversed hot and neutral wiring, it is essential to use a more reliable receptacle tester, such as a polarity tester or a 3-light tester. Polarity testers are designed to specifically identify reversed polarity conditions. These testers use a combination of lights and audible signals to indicate whether the hot and neutral wires are connected to the correct terminals. 3-light testers are another type of receptacle tester that can provide more detailed information about the wiring condition of the receptacle. These testers use 3 lights to indicate various wiring conditions, including reverse polarity, open ground, and other faults. In addition to using reliable receptacle testers, it is also important to follow proper wiring practices when installing or modifying electrical receptacles. This includes ensuring that the hot, neutral, and ground wires are connected to the correct terminals, using the appropriate wire size and type, and following all applicable electrical codes and regulations. It is also crucial to regularly inspect electrical receptacles for any signs of damage or wear. Damaged or worn receptacles should be replaced immediately to prevent electrical hazards. Some common signs of receptacle damage include cracks, loose connections, and discoloration. When replacing electrical receptacles, it is important to turn off the power to the circuit at the circuit breaker or fuse box. This will prevent electrical shocks during the replacement process. It is also important to use the correct type of receptacle for the application. For example, ground fault circuit interrupter receptacles should be used in areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Electrical safety is paramount in any electrical system. Taking the necessary precautions and using the right tools and techniques can significantly reduce the risk of electrical hazards and ensure the safe and reliable operation of electrical equipment. In addition to the risks associated with reverse polarity, there are other potential wiring errors that can affect the safety and functionality of electrical receptacles. These errors include open ground, open neutral, and hot and ground reversed. An open ground occurs when the ground wire is not properly connected to the grounding system. This can create a dangerous situation because the grounding system is designed to provide a safe path for stray electrical current to flow back to the power source in the event of a fault. If the ground wire is not connected, the stray current may flow through unintended paths, such as through a person who comes into contact with an energized metal part of an appliance. An open neutral occurs when the neutral wire is not properly connected to the neutral bus bar in the electrical panel. This can cause a variety of problems, including voltage fluctuations, equipment malfunction, and electrical shocks. In a properly wired circuit, the neutral wire provides a return path for the current back to the power source. If the neutral wire is not connected, the current may flow through other paths, such as through the grounding system or through other appliances. Hot and ground reversed occurs when the hot wire is connected to the ground terminal on the receptacle, and the ground wire is connected to the hot terminal. This is a dangerous condition that can create a significant risk of electrical shock. In a correctly wired receptacle, the ground wire is connected to the grounding system, which is designed to provide a safe path for stray electrical current to flow back to the power source. If the hot and ground wires are reversed, the grounding system may become energized, meaning that it is carrying electrical current. If a person touches a grounded metal part, they could receive an electrical shock. To prevent these wiring errors, it is essential to follow proper wiring practices when installing or modifying electrical receptacles. This includes ensuring that all wires are connected to the correct terminals, using the appropriate wire size and type, and following all applicable electrical codes and regulations. It is also important to use a reliable receptacle tester to verify the wiring of the receptacle after it has been installed or modified. Regular electrical safety inspections are also crucial for identifying potential wiring errors and other electrical hazards. These inspections should be performed by a qualified electrician who can thoroughly examine the electrical system and identify any problems that need to be addressed. During an electrical safety inspection, the electrician will typically check the wiring of receptacles, switches, and other electrical components. They will also check the condition of the electrical panel, wiring, and grounding system. Any wiring errors or other electrical hazards that are identified during the inspection should be corrected immediately to prevent potential electrical shocks, fires, and equipment damage. Electrical safety is a shared responsibility. Homeowners, business owners, and electricians all have a role to play in ensuring the safe and reliable operation of electrical systems. By following proper wiring practices, using reliable testing equipment, and conducting regular electrical safety inspections, it is possible to significantly reduce the risk of electrical hazards and protect people and property from harm. In addition to the above, consider the following points regarding electrical receptacles and their safe use. Firstly, never overload electrical receptacles. Overloading can cause the receptacle and wiring to overheat, increasing the risk of a fire. Secondly, use surge protectors to protect sensitive electronic equipment from voltage spikes. Voltage spikes can damage electronic equipment and shorten its lifespan. Thirdly, avoid using extension cords as a permanent wiring solution. Extension cords are intended for temporary use only. Fourthly, replace damaged or worn extension cords immediately. Damaged or worn extension cords can pose a fire hazard. Fifthly, keep electrical receptacles and cords away from water. Water can conduct electricity and create a risk of electrical shock. Sixthly, never attempt to repair electrical receptacles or wiring yourself unless you are a qualified electrician. Electrical work can be dangerous and should only be performed by trained professionals. Seventhly, be aware of the location of the electrical panel and know how to turn off the power in case of an emergency. Eighthly, educate children about electrical safety. Teach them not to play with electrical receptacles or cords. By following these safety tips, you can help prevent electrical hazards and ensure the safe and reliable operation of electrical equipment in your home or business. Also, remember that electrical codes and regulations vary from jurisdiction to jurisdiction. It is important to be familiar with the electrical codes and regulations in your area and to follow them carefully when installing or modifying electrical receptacles and wiring. Local electrical codes are in place to protect people and property from electrical hazards, and they should be adhered to at all times. If you are unsure about any aspect of electrical safety, it is always best to consult with a qualified electrician. A qualified electrician can provide expert advice and guidance on electrical safety matters and can help you ensure that your electrical system is safe and up to code. For example, the National Electrical Code Section 210.7 addresses the requirements for the identification of grounded conductors, also known as neutral conductors. This section specifies that the grounded conductor shall be identified by a continuous white or grey color. This helps to ensure that the grounded conductor can be easily distinguished from the ungrounded conductors, also known as hot conductors, which are typically black or red in color. The proper identification of grounded conductors is crucial for preventing wiring errors and ensuring the safe operation of electrical equipment. Similarly, the National Electrical Code Section 250.119 outlines the requirements for the identification of equipment grounding conductors. This section specifies that the equipment grounding conductor shall be identified by a continuous green color or a continuous green color with one or more yellow stripes. This helps to ensure that the equipment grounding conductor can be easily distinguished from the other conductors in the circuit. The proper identification of equipment grounding conductors is crucial for providing a safe path for fault current to flow back to the power source in the event of a ground fault. Other sections of the National Electrical Code address various aspects of electrical safety, including the installation of ground fault circuit interrupters, the proper wiring of receptacles and switches, and the protection of electrical equipment from overcurrent. By following the requirements of the National Electrical Code, it is possible to significantly reduce the risk of electrical hazards and protect people and property from harm. Also consider the differences between electrical systems in different countries. In North America, the standard voltage for residential electrical systems is 120 volts, while in many other countries, the standard voltage is 230 volts. This means that electrical appliances and equipment designed for use in one country may not be compatible with the electrical system in another country. When traveling to a foreign country, it is important to check the voltage and frequency of the electrical system and to use a voltage converter or adapter if necessary. Voltage converters and adapters can be used to convert the voltage and frequency of the electrical system to match the requirements of the appliance or equipment. Additionally, different countries use different types of electrical plugs and receptacles. It is important to use the correct type of adapter to ensure that the appliance or equipment can be safely plugged into the receptacle. Using the wrong type of adapter can damage the appliance or equipment and may also pose a safety hazard. If you are planning to travel to a foreign country, it is a good idea to research the electrical system in that country and to purchase the necessary voltage converters and adapters before you leave. This will help to ensure that you can safely use your electrical appliances and equipment while you are traveling. Consider GFCI and FSI protection as well. Ground fault circuit interrupters are devices that are designed to protect people from electrical shock. They work by monitoring the current flowing through a circuit and detecting any imbalance between the hot and neutral wires. If an imbalance is detected, the GFCI will quickly trip the circuit, cutting off the flow of electricity and preventing an electrical shock. Arc fault circuit interrupters are devices that are designed to protect against electrical fires. They work by detecting arc faults, which are dangerous electrical discharges that can occur when wires are damaged or insulation is worn. If an arc fault is detected, the FSI will quickly trip the circuit, cutting off the flow of electricity and preventing a fire. GFCI protection is typically required in areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. FSI protection is typically required in bedrooms and other areas where there is a high risk of fire. By installing GFCI and FSI protection, it is possible to significantly reduce the risk of electrical shock and fire in your home or business. Electrical panels are the heart of an electrical system. They distribute electricity throughout a building and provide overcurrent protection for individual circuits. It is important to understand the basic components of an electrical panel and how they work. The main components of an electrical panel include the main breaker, circuit breakers, and bus bars. The main breaker is the primary overcurrent protection device for the entire electrical panel. It is designed to trip and shut off the power to the entire panel if the current exceeds the rated capacity of the panel. Circuit breakers are individual overcurrent protection devices for each circuit in the electrical panel. They are designed to trip and shut off the power to a specific circuit if the current exceeds the rated capacity of the circuit. Bus bars are metal strips that distribute electricity from the main breaker to the individual circuit breakers. They are typically made of copper or aluminum and are designed to carry a high amount of current. When working with an electrical panel, it is important to follow all safety precautions. Always turn off the power to the panel before working on it and use insulated tools to prevent electrical shock. If you are not comfortable working with electrical panels, it is best to consult with a qualified electrician. Here are some common electrical safety rules to follow. Never touch electrical wires or components with wet hands. Always use insulated tools when working with electricity. Turn off the power before working on any electrical circuit. Never overload electrical circuits. Use ground fault circuit interrupters in areas where there is a risk of electrical shock. Inspect electrical cords and appliances regularly for damage. Replace damaged electrical cords and appliances immediately. Keep electrical cords and appliances away from water. Never run electrical cords under rugs or carpets. Be aware of the location of overhead power lines. Stay away from downed power lines. Never climb on utility poles or towers. Educate children about electrical safety. By following these electrical safety rules, you can help prevent electrical accidents and protect yourself and others from harm.